This is the pancake toss and its velocity due to gravity and height and the time it takes. This is where it's starting at from the pan on my waist, which is 0 feet or 0 inches. This is my entire body, 32 inches, and then 2 inches from the pan going up. Then 27 inches in total, its max height from the pancake to my waist ish. The problem is that Ian tosses a pancake in the air starting from his waist, y equals 0 inches. It reaches 27 inches upward from his waist. A, part A, if the pancake leaves the pan, which is 10 inches from his waist, how fast does he need to toss it? Part B is how long does it take to hit the pan again at his waist? You may ignore air resistance throughout this entire problem. So that's kind of like what the problem is. Um, and if the, we're looking for time and we're looking for velocity. Here are my diagrams. I have 32 inches of the entire body from the waist, starting at 0 inches. Then I have the velocity 1 going up, then 10 inches from the waist from the pan, and then a little extra 2 inch nudge from the pan to the pancake. And then finally, the velocity 2, which is at its final height at 27 inches, and the velocity 3 coming back down. Givens are neglect air resistance, initial height, which is h equals 0. Final height is h final equals 27 inches. The height from the pan to the waist is hp equals 10 inches. Some assumptions we can use is gravity is present, which is 32 feet per second squared. The neglect the mass of the pancake, and the height of Ian is not needed. So those are the assumptions that we can assume when we're looking at the problem. Sorry, my thing's not working. Hello. So to solve this problem, you must utilize some kinematic equations. Y equals y initial plus v initial times delta t plus 1 half a times delta t change in time squared. This relates y and t. Then we have v equals v initial plus a times change in t, again, change in time, which relates velocity in time. And then we have v squared equals v initial squared plus 2 times the acceleration times the change in height. So substituting, or some key concepts we have here is substituting the kinematic equations, knowing when to appropriately use the equations, and the conversion, which is due to, I have an error here. It should be 32.2 feet per second. And thank you so much for watching. I hope you enjoyed, and thank you again for watching.